Now, I'm not going to waste a lot of time here going through the actual ins and outs of how the actual technology works. The basics of it, though, are that if you picture here that you have this is just an example of a platter. So, those read write heads that you saw at the end of the actuator arm, well, actually, that arm, you saw it on top of the platter, but actually it goes both on top and on the bottom of the platter. So, those platters are two sided. And they use an analog magnetic field, or what becomes an analog electrical current that is used. And again, when it comes to magnetics, you have polarity, right? And you have, north and south polarity, okay? Or some say positive and negative polarity. And based upon which way the polarity is, you're going to create a 1 or a 0. And you switch the polarity through this thing called flux reversal. Now, beyond that, feel free to read up all about it if you really want to know what's going on inside of a hard drive, but that's the basic gist of it. What is important that you understand is the actual geometry of the hard disk. All right, so first of all, that platter that you saw in most hard drives, it's not platter, but it's the plural. It's platters. There's multiple platters. Okay, so on that spindle, you end up with a stack of platters. And you have those actuator arms and read write heads that go on top and underneath each one of them. So you have a bunch of arms going in and writing to all these various platters. Now, on these platters, I'm going to ask you to focus on the lower left-hand corner of the screen here where I point out what a track is. Okay, so if you picture on any given platter, there is a track, right? And it's one line basically that goes all the way around the platter. If you go up to the top left portion of the screen, I point out that one section of the track is known as a sector. Now, I will tell you that this sometimes gets a little confusing because sometimes you'll see in different publications, you'll see like the entire pie piece, so to speak, all the way from the center all the way out to the edge as being a sector. And that's actually something known as a disk sector. Okay, but the sector, for the sake of the geometry here and some of the math, is just the one little piece on that track. From there, if you move to the right, you'll see I have something called a cluster. And it looks like, from the illustration, it looks like I'm highlighting two sectors. And that's not necessarily the case. A cluster has to do with the smallest amount of data that can be written to the disk. Okay, so depending on exactly how a disk is formatted and what file system you're using, there are different cluster sizes, and the cluster represents the smallest piece of data that can be written. And it is usually bigger than a sector. Okay, it might be a sector and a half, might be two sectors, might be three, it could be any number of sectors. One thing I will tell you about a sector, by the way, is a sector is a finite amount of data. A sector holds 512 bytes of data. Okay, so that would be half of a kilobyte, right? Now, I should clarify that in a traditional hard drive, a sector holds 512 bytes. The reality is that there are certain hard drive technologies where that actually has been modified, but I don't want to go there. I just want to go with the standard. Just keep in mind the standard is 512 bytes. Now, the one last component that I want to point out to you here is in the lower right-hand corner of the screen, and it is something called a cylinder. A cylinder is basically if you take one of the tracks on a platter and have that same track on every platter going all the way down through the spindle. Okay, so some hard drives will say that they have X number of cylinders. Right? If you look at the specs on the hard drive, it'll say X number of platters, X number of cylinders. However many cylinders it says that it has, that's how many tracks are on each platter. Okay, so really the cylinder is just a track going down through all the platters. So let's talk about some of the pros and cons to using, these typical magnetic hard disks. I mean, as far as the pros, they can be fairly high capacity, right? In the sense that, I mentioned that we have terabyte drives, and you can get a terabyte drive for, I even priced it today, but I want to say, 50, 60, $1,000, you can buy a terabyte of storage. So you can definitely get decent capacity at a low cost. They do come in different form factors, so many different shapes and sizes. You do have 3.5 inch, you have bigger 5.25 inch, you have 2.5 inch for your laptops. I mean, you have a lot of different shapes and sizes. Some of the cons is that it's vulnerable to EMI. Now, EMI stands for electromagnetic interference. So I don't know that it's very vulnerable to the actual interference, the way we typically think of EMI. But the bottom line is because it's magnetic, other magnetic things can cause problems. I mean, you ever want to erase a hard drive real fast? Put a high powered magnet on it. So, what is another con? They definitely can be damaged and they do fail because there are a lot of moving parts. And as a whole, they're not the best performing drives. I mean, they're not the worst either. I mean, I will tell you the performance is going to have a lot to do with the speed, and that is one of the things that you want to keep in mind is that your typical hard disk will be rated as 5400 RPMs. And if you picture that these disks are spinning, RPM is revolutions per minute or rotations per minute. I mean, a lot of people use a different word for the letter R there, but basically it's going to spin 5400 times all the way around per minute. They come with 7200 RPM, 10,000 RPM, and even some of the more expensive ones are 15,000 RPM. And I would say when you get to the point of a 15,000 RPM hard disk, that's going to perform pretty well. It's not that slow anymore.